Hi everyone, this is the 8th video of our series called Essential Skills for Mechanical Engineers. In this video, we are going to talk about power plant design. A power plant is an industrial facility that generates electricity from a primary source of energy. Though electrical engineers are responsible for the distribution of electricity, the design and functioning of the power plant is solely a mechanical engineer's responsibility. Mechanical engineers play a crucial role in the design, operation, maintenance, and optimization of power plants. First, let us talk about what these various roles are. Mechanical engineers contribute to the design and engineering of power plant components and systems, including boilers, turbines, generators, heat exchangers, pumps, and piping systems. They use computer-aided design software to create detailed engineering drawings, specifications, and calculations for equipment and systems. Mechanical engineers ensure that the design meets performance, safety, and regulatory requirements while optimizing efficiency and reliability. Mechanical engineers are involved in the selection and procurement of equipments and materials for the power plant, such as turbines, boilers, valves, and piping. They evaluate suppliers, review specifications, and negotiate contracts to ensure that the equipment meets quality standards, specifications, and project schedules. During the construction phase, mechanical engineers oversee the installation, assembly, and integration of mechanical equipment and systems. They work closely with construction teams to ensure that equipment is installed correctly according to design specifications and industry standards. Mechanical engineers participate in commissioning activities to test and verify the functionality, performance, and safety of mechanical systems. They conduct performance tests, troubleshoot issues, and ensure that equipment operates as intended before the plant is put into service. Engineers are responsible for the operation and maintenance of mechanical systems within the power plant. They develop and implement maintenance schedules, inspection procedures, and prepare plans to ensure the reliability and efficiency of equipment. Mechanical engineers troubleshoot equipment failures, diagnose issues, and implement corrective actions to minimize downtime and maximize uptime. Mechanical engineers monitor the performance of mechanical systems, analyze operational data, and identify opportunities for optimization and efficiency improvements. They implement measures to enhance equipment performance, reduce energy consumption, and optimize plant operation. Mechanical engineers ensure that mechanical systems comply with safety regulations, codes, and standards applicable to power plant operations. They participate in safety audits, risk assessment, and incident investigations to maintain a safe working environment and mitigate hazards. Overall, mechanical engineers play a crucial life in the life cycle of a power plant, from design and construction to operation and maintenance, contributing to the reliable and efficient generation of power. Now we will come to the top skills that you need to have if you want to become a power plant design engineer. First important skill is to know what are the different ways in which we can generate electricity. We can also say these are the types of power plants. Nowadays, there are a lot of different types of power plants. However, these can be broadly categorized as thermal power plants and renewable resource power plants. In case of thermal power plants, fuel is burnt to produce heat, which converts water into steam, and this steam is used to run the turbine. While in case of renewable resources, the source itself helps run the turbine. There are 5 types of thermal power plants in common knowledge. Thermal power plants either use coal, diesel, natural gas, geothermal, or nuclear energy as a fuel to produce heat. Coal-fired power plants use steam coal as a source to generate electricity and consequently emit a significant amount of harmful gases into the atmosphere. In a bid to reduce greenhouse gas emissions, many developed nations have already announced plans to phase out coal-fired power plants. Diesel-fired power plants are used for small-scale production of electric power. They are installed in places where there is no easy availability of alternative powerhouses and are mainly used as a backup for uninterrupted power supply whenever there are outages. Diesel plants require only a small area to be installed and offer higher thermal efficiency compared to coal-fired power plants. Due to the high maintenance costs and diesel prices, the power plants have not gained popularity at the same rate as other types of power generation plants such as steam and hydro. A gas-fired power plant burns natural gas, a rapidly growing energy source across the world, to generate electricity. Although natural gas is a fossil fuel, the emissions produced from its combustion are much lower than those from coal or oil. Another type of plant that uses gas is a combined cycle power plant. Using both gas and steam turbines, they produce higher amount of electricity from a single fuel source compared to a traditional power plant. They capture heat from the gas turbine to increase power production and are also found to release low amounts of harmful gases into the atmosphere. There are 3 main types of geothermal plants, including dry steam power stations, flash steam power stations, and binary cycle power stations, all of which use steam turbines to produce electricity. The installed capacity of geothermal energy has gradually increased worldwide over the past decade. Geothermal power plants are considered to be environmentally friendly and emit lower levels of harmful gases compared with coal-fired power plants. Using a nuclear fission reaction and uranium as fuel, nuclear power plants generate a high amount of electricity. As nuclear power plants are considered to be a low-carbon energy source, the technology is widely thought of as a more environmentally friendly option. When compared to renewable sources of energy such as solar and wind, the power generation from nuclear power plants is also considered to be more reliable. Although the investment required to bring a nuclear power plant online is significant, the costs involved in operating them are relatively low. Nuclear energy sources also have a higher density than fossil fuels and release large amount of energy. Due to this, nuclear power plants require low quantities of fuel but produce a vast amount of power, making them particularly efficient once they are up and running. Moving to energy generation from renewable resources, we have been successful in tapping the energy from flowing water, wind, and the sun in various farms. Hydroelectricity is produced by harnessing the gravitational force of flowing water. Compared to fossil fuel-powered energy plants, hydroelectric power plants emit fewer greenhouse gases, but the construction of hydroelectric power plants and dams require huge investment. Solar energy plants convert energy from the sun into thermal or electrical energy using one of the cleanest and most abundant renewable energy sources. They generally do not require high maintenance and last about 20 to 25 years, but the initial costs involved in financing solar power plants are high and installation requires a lot of space. Another similar technology is solar thermal. It is a system of giant mirrors placed accordingly to concentrate the sun's rays on a very small area to create a significant amount of heat, which then produces steam to power a turbine that creates electricity. In recent years, there have been a rapid growth in the number of wind farms across the world, underpinned by technological advances. After the wind turbines are built, operational costs involved in maintaining wind power plants are low. They are generally considered to be relatively cost effective. Wind farms can also be constructed on agricultural lands without causing any interruption to cultivation activities, but the maintenance of wind turbines may vary, as some need to be frequently checked and wind power projects typically require huge capital expenditure. Tidal energy is generated from converting energy from the force of tides into power, and its production is considered more predictable compared to wind energy and solar power. But tidal power is still not widely used. Even though the world's first large-scale plant of this type became operational in 1966. An increased focus on generating power from renewable resources is expected to accelerate the development of new methods to explore tidal energy. Although the development of tidal power is at a nascent stage, it has the potential to grow significantly in the coming years. Once you know about the different available options for generation of energy, the next big thing is to know how to select the right power plant for the project. One of the first things to consider when choosing a power plant is the type and cost of fuel that will be used to generate electricity. Different fuels have different advantages and disadvantages in terms of availability, price, efficiency, emissions, and storage. For example, coal is abundant and cheap, but it has high carbon dioxide and other pollutants, and it requires large storage and transport facilities. Natural gas is cleaner and more efficient, but it is subject to price fluctuations and pipeline constraints. Renewable resources such as wind and solar are environmentally friendly and have low operation costs, but they are intermittent and depend on weather conditions and grid integration. Therefore, you need to evaluate the fuel options based on your project's specific needs and constraints. Another important factor to consider in the demand and location of electricity that your power plant will serve. Different power plants have different capacities, load factors, ramp rates, and flexibility to respond to changes in demand and supply. For example, base load plants such as nuclear and hydro have large capacities and high load factors, but they are inflexible and require long-term planning and investment. Peaking plants such as gas turbines and diesel generators have smaller capacities and load factors, but they are flexible and can start and stop quickly to meet peak demands. Intermediate plants such as combined cycle gas turbines and biomass have medium capacities and load factors, and they can adjust to varying demand and supply. Therefore, you need to match the power plant type to the demand profile and location of your project. A third factor to consider is the regulatory and social requirements that your power plant will have to comply with. Different power plants have different impacts on the environment, the economy, and the society, and they are subject to different laws, regulations, standards, and incentives. For example, fossil fuel plants have to comply with emission limits, carbon taxes, and environmental permits, while renewable plants may benefit from subsidies, feed-in tariffs, and green certificates. Additionally, you need to consider public acceptance and social license of your power plant, as some types may face more opposition or support from local communities, stakeholders, and customers. Therefore, you need to assess the regulatory and social requirements that affect your power plant choice and feasibility. The fourth factor to consider is the technical and operational characteristics of different power plant types. The different power plants have different designs, components, systems, and processes that affect their performance, reliability, maintenance, and safety. For example, thermal power plants have boilers, turbines, generators, condensers, cooling towers, and other equipment that require regular inspection, cleaning, and repair. Renewable power plants have inverters, converters, transformers, and other devices that need to be synchronized and controlled with the grid. Nuclear power plants have reactors, fuel rods, control rods, and other components that involve complex and critical operations and procedures. Therefore, you need to understand the technical and operational characteristics of different power plant types and how they affect your project's objectives and outcomes. The final step in choosing the right power plant for your project is to compare and evaluate different options based on the factors that we have discussed. You can use various methods and tools such as cost-benefit analysis, life cycle assessment, multi-criteria decision analysis, simulation models, and optimization algorithms to weigh the pros and cons of different power plant types and find the optimal solution for your project. You can also consult with experts, stakeholders, and customers. By doing a comprehensive systematic comparison and evaluation, you can ensure that you choose the right power plant for your project and achieve the best results. The third important skill is the knowledge of software tools. There are many software tools available for power plant design such as Aspen Plus, Epsilon Professional, Thermoflow, GateCycle, and Homer. These tools can help you perform tasks such as mass and energy balances, thermodynamic cycles, equipment sizing, cost estimation, and environmental impact assessment. You can also use software tools to compare different power plant configurations, scenarios, and alternatives. The fourth important skill is the knowledge of various technical standards for power plants in whichever countries you are working in. In India, the Central Electricity Authority has published technical standards for construction of electrical power plants and electric lines in 2022, which clearly states the definitions of various terms associated with power plants, general requirements for power plants, technical standards for construction of thermal and hydroelectric power plants covering very minute details straight from site selection to ash handling and beyond. It also includes the design requirements of ash handling systems as well as protections required for thermal and hydro power plants. Fifth is the knowledge of regulations regarding power plants. Though the generation of electricity is a delicensed subject in India, construction, operation, and maintenance of power plants require permits, consent, and approvals regarding land acquisition, environmental safety, corporate and labor employment, use of restricted lands, and pollution control. So it's necessary to know about the regulations of each of these departments. Also, nuclear power plants can only be government owned Hence, there is a separate regulatory body for it. Engineering of each and every type of power plant is different and covers a vast range of topics. Design of each system requires special skills. At UpSkul, we have expert mentors who train these skills and help you get into your dream job. Thanks for watching this video. See you in the next one.